RBX, brand new.
Ron, AD0EH.
Mike, DC0PV.
Tom, KD0HF.
Jeff, AD0AK.
Jules, KW0Y.
Ron, N0IQN.
Gary, K0GT.
Barry, W0IY.
Rod, K0DAS.
Bill, N0LNO.
Tim, KC0DM. Mike, KC0 and handstand.
Dave, WA9HBC.
Larry, K0MTN.
Bob, KW0O.
Larry, WA0FBH. Nathan, KD0. Marco, KD0RBU.
No letters.
Oh,
Not yet.
How about an A?
Evie.
Evie, nice. Glad you could come.
3 months from now, we'll see. That's my stretch goal.
Oh, okay, good.
Sarah, no letters yet. Same thing.
Outstanding.
Steve, newbie as well.
All right.
Joe, WB0YSL.
What?
You want me to go again?
Yeah.
Mike, AD0PV.
Okay, some old business. The treasurer's not here. So I don't know how much is in the treasury. Been spending like mad.
See that?
Yeah.
A drunken sailor, if you get the point.
Yeah, that's right. That's right. It's nice radio. Should go down to Maine. It'll be at Maine plant. I'll get to that in a moment. Eastern Iowa Science and Engineering Fair report. Yes.
So I want to thank the Collins Amateur Radio Club as well as the Cedar Valley Amateur Radio Club for their support. We did at the fair on St. Patrick's Day in Lindale Mall about 200 exhibits from junior high and senior high school students. We selected one at the junior level, one at the senior level, and gave them their prizes, which at the junior level included the tech manual so they can get their license. And at the senior level, the ARRL handbook, so they can figure out how to make their graphics better. Had help from Dave Maley, UA0ZZG. So, and again, be thinking about this next year, around that time, St. Patrick's Day-ish. Always use more volunteer judgment to help us come out and look at all the great exhibits students have.
I was one of the judges. Kind of interesting. The range, some of the kids really had their speech down. Boy, did they lay it on you. Wham. Other kids were kind of like, you know, I did, and sure, it must have worked. My mom said it did. Okay. Okay. So that's kind of an overview there. This is how it stands so far. I don't think anybody's been running down the street getting away. So there's a few open spots. If somebody would like to take programs, that would be really nice. So I think the COP is still going on, right? Not a really for those that's already in the business, but anyway, okay. The 6600M. I don't know what their replacement for the 67 is going to be, but this one has 2 receivers, where the 67 has 2 receivers. So you can do diversity on it, which works pretty well. The other night I just had, you know, WWV dialed up and I selected diversity. It comes out one out each speaker. And you can just hear it move from side to side as it's fading. So you can turn the knobs here. That's not much antenna inside of a building. That's a lot to ask for somebody to a radio to suck up signals inside of a steel building. But so have a look at it. I'm taking it down to main plant. Now we have a Flex 5000A for sale. They're going for about $1,200 or make an offer. It'll be out, if somebody doesn't take it before that, it'll be out at the Junk in the Trunk. And I guarantee there's going to be a bunch of free stuff there. Treasures that you really want to take. Somebody wants to take them home. There'll be radios and all kind of fun stuff right here. May 12th, Saturday. That's the weekend before Dayton. And be right out here in this parking lot. 8 o'clock. Got to come early to to get the good deals, you're going to have to get here early now. And so there's no prizes, no talk-ins, no refreshments unless somebody brings some. This is it. So I have no idea what the weather's going to be. And so please come. Okay. In addition, there is activity happening August 4th and 5th. Normally it's just a Sunday morning. Well, this here will be pretty much all day Saturday and a portion of Sunday. Lynn County Fairgrounds out at Central City. It's going to be a really big deal. And the man's not even here to talk about it tonight. Tim is supposed to talk about that. So we're looking for suggestions how we can be involved. One of the thoughts was to take one of the old Collins radio from the club station out there and set it up, put it up an antenna and stuff. I'll probably keep the microphone off of it, but you know, you can tune it and play with it and stuff. So that's one thought. Any other ideas? We'd certainly love to do that. We do have a remote 6700 that has been loaned to the club for a while. It's set up out at Adrian's, has two crossed off-center fed dipoles, usually called a Wyndham antenna. So you can switch between 1 and 2, and if you go diversity on that one, you hear it coming out 2 speakers, and the antennas are at 90 degrees to each other, equally matched. So it's kind of interesting on that one too. Basically, if you want to operate that, all you need is a computer with a mouse and internet activity. If you're not going to talk, you don't need a mic. And the flex control knob will work. You plug it in your radio. Talk to the president, he'll get you signed up. Okay, what's happening? Well, the Whisper station is still running. All the radios up, antennas up. Come over and use the 112 station. And there's a few things that could be done over there. The K3 has a 2-meter unit in it, and there's an amplifier with a LNA in it. So it would be, if we could hook that up, that would be good.
Up at the 112 station, is the S-line up and fully functional, including the 30S1?
After Rod repaired that thing, there seems to be more wires than there's plugs to plug it into. I wasn't alone on this one. So we need an extra, what's that? Well, I was looking at the manual and I can't see where it plugs into. It doesn't go into transmit. It doesn't go into, when you say transmit, it doesn't.
That's someone to look at, okay.
Yeah.
It did what I used it.
Well, I tell you, there you go. Oh, all right, I appreciate that. So the other stage, main plant, we've got lots of antennas. So you can really do diversity down there because we got lots of antennas. And HF radios and amplifiers and everything. And now this bad boy will be down there. So you just select the radio you want and you select the antenna and off you go. We're real close to getting the horizontal, vertical, up on 2 meters and 440 for talking to satellites. That's real soon now. All right? And we just need to finish hooking up the satellite station. You guys can come through. It is interesting, the 9100 also is an HF rig. So it does 160 through 70 centimeters. So that's on the panel here. It's labeled right here now. So you can use that one also. And it has 2 receivers, so you can do diversity with that one also. And, finish up the UHF, the satellite station. Blah, 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 blah. Oh yeah, 8-wire lightning arrestor.
The big setup to finish up is get the satellite station up and running. The hardware
Yeah.
deploy, so we get the software in.
Right.
Good to go.
Yeah, we're just about ready to invite the expert in. Wyatt's going to do that. So, today, calling somebody in to give us a talk.
Okay, don't we have a business item?
A business item. What was that?
Job state station.
Oh, yeah, I was going to put that in there and I totally forgot it. You want to give us a rundown? You're a little closer than I am on that.
So, this has already been through the executive committee, and nobody, and I mean, nobody on the executive committee said no, but we thought we ought to talk about it with everybody. The ISU station, which some of us have ties to, some of us more close than others, the Iowa State Public has really gone through quite a bit of turmoil with respect to building renovations. And they used to have a nice HF station set up there, but through renovations, it kind of got torn down. And they've got all the pieces, okay, with the exception of they need to get it on the outside of the building so that they can work. We talked about offering a radio, and it's like, my son gave me a special tour a couple weeks ago. I think they've got a radio for every band, 60 through 440. And I really don't think they need a radio, and they're all really, even the old ones are looking at radios, but the new ones are looking at radios too. They might be a little bit feedline scarred, but they've got hardline. I mean, they've got a lot of good stuff in there. And really, all they're asking for is a donation so that they can get the physical plant to do a little bit of work for them. The executive, you guys let you know what's going on. It's been long enough, Charlie. Do you remember the amount it was like on the order of $3,000 or something?
Well, that's what they were asking for. I don't know if, so we need to decide on what that number should be that we would put up.
And the scope of that bill is primarily for the infrastructure, the tower, put up the towers.
Get a chunk of tower, put on the building in a way that everybody will be happy.
Right.
It's really, it's not much more than that. They've got antennas and boxes. I mean, he says, we don't need this, we don't need this. What we need is just this little bit of money to get us where we can.
They have to pay the physical plant people.
Yeah.
Is there any,
That's how it should be, right?
is there anybody else that's willing to step forward? Are we planning on putting the whole thing up?
They have done a lot of outreach to other companies for stuff. They're looking, I asked that question, and the answer was, well, they don't have anybody else for this yet.
So what's the chance of somebody else stepping up if we put up some?
Say that again?
What's the chance of somebody else stepping up if we put up?
They're not asking right now, so it's kind of low.
Oh.
So,
So it would be the idea of we agree to put up X and we put that in reserve until they need it.
until we actually make the transfer occur. Yeah.
So it would stay with us until that happens.
Project is $3,000.
I think that's about right, yeah. That's what I remember.
One option we could do is, say, match up to 1,500, so that would encourage you to go with the other thing.
Well, I was gonna ask, for the solar car, if you make donations to the Iowa Foundation, whatever that's called, then Rockwell will give matching funds.
Ooh.
But, so before you pull the trigger, we ought to at least ask that question.
That's a good question, but also at least the matching fund policy was that there was a cap. They would match up to like X, and it was like $5,000. So at one time, I don't know what it is today. But the other thing is we probably want to hurry up and do it before we become UT.
Oh, before school.
That too.
Yes, no.
Does this purpose fit into
Our charter?
Rockwell's purpose for the money they give us?
Well, we could call this our own money that we get from dues and selling equipment. We could call it that, but I'm sure they would be real happy with that, you know, helping STEM. And that's, I put it in there that we, you know, keep it in, so that they know that. I think that'd be a great, I didn't know that at the time to put it in, that's what we were asking money for, but we could do that, yes.
Well, we could approach Rockwell and say, we're considering donating for STEM purposes some money out of the state where they like to match that.
Right.
But also, 3K sounds a little low. I wonder if those guys that actually have facilities and have concrete slopes.
Well, it depends on what they're trying to do. I mean, the crane rental was $8,000, I doubt they're using anything with the crane. There's probably guys up on the roof bolting on brackets to existing brick structure and things like that.
Yeah. I think they've done the diligence. I do. So, and by the way, they've had, on the physics building, they had power. They've done this before. So, go ahead.
Times before, when the club supported significantly some effort like buying a radio, that we had a pretty good idea of what we were getting. We had a list, the radio was this much, options would be this much. I'm not getting that high from this one. This is really, really nebulous considering the amount of money that is being
That's fair. That's
if
fair.
we had a list of proposal, a paragraph or two, that we could say, yeah, this is exactly what we're supporting, instead of saying, yeah, we're doing good for a bunch of students. You know, that would.
That's an engineer kid, Rockwell engineer kid. Show me the.
It would also work better, you know, at the end of the year when we say, here's what we've supported. We say, look, here's half a page, or on specifically how we help them accomplish what they needed to do.
Oh, yeah. Well, apparently, they have all the equipment. It's just getting the tower. They even have the tower, right?
I don't know if they've got that yet or not. I got a feeling that's pretty easy for them to get.
Yeah.
They are well connected. In fact, they became even better connected this past spring.
Yeah.
Yeah.
Bill, since they keep away from
Given money to the Iowa State Club so they can get their station actually get a whole power section on their building.
I don't feel that.
So,
Even though I don't have kids, I need to do that.
Well, anybody want to make a proposal, make a motion?
I'm going to press for Mike to make it because he sounds like he's got the right conditions. But I'd like it to be worded in a way that the executive committee can execute. Okay? You can require due diligence, all stuff that.
Right.
Okay.
So this motion would authorize, I move that we authorize the executive committee to proceed with supporting Iowa State subject to having a written description we're going to do with some kind of timeline so that it's not just and a maximum dollar amount, and also ask the executive committee to pursue matching grant opportunities within Rockwell College.
And
It's a friendly amendment, yeah, let's put a cap on it.
What would that be? 1,500?
They asked for $3 grand for it.
2K?
How much?
2K? So they get some skin in the game.
I think you're right. We need to put a limit on it. And 2,000 is pretty significant, but it's not open-ended. Okay.
You want to read that back, and they will have a vote.
All right. So Mike moves to authorize the executive committee to proceed to support Iowa State Amateur Radio Club as long as they provide a written description with timelines and a maximum dollar amount. And we're going to pursue this with a cap of $2,000 with a match.
With the match. Anybody want to second that? Rob seconds it. All of it say for it, say aye.
Aye.
Against by the same sign? Okay, it has passed. Thank you. All right. We'll want pictures and activities, and we want to be able to talk to them on the radio.
That's right.
QSL card.
By the way, I think they made
What?
quite a few contacts.
No, you can start talking now. Okay, so today, Tim is going to give us a rundown on some of the experimentation he's been doing with ferrite rod. Kind of an interesting thing to be found out.
This thing on?
It is on.
It is on. All right.
If you want a microphone,
No, I don't think I particularly need a microphone. This is for the video, right? Sound. Okay. All right. Let me start with what I've been doing. I've been playing, right? Everybody's familiar with the classic loop stick antenna and how it works on little radios at low frequencies. I'm moving up into higher frequencies, so I bought 20 half-inch by half-inch diameter, 7.5-inch long ferrite rods from Amadon, type 61 material that works up into the HF band, and we will look at what I've done with it. Different things. Okay, what I did is I was comparing the differences between short ferrite antennas, physically short, electrically short, and wire antennas. I have a 260-foot off-center fed dipole. I have crossed ones. I have 2 of them. So a very long piece of wire. I have horizontal beam, vertical ground plane on top of a 40 by 60 foot Morton building, so it's got a very good ground plane on it. So good antennas, and I'm comparing these little runt antennas to these very physically large antennas. The ferrite antennas are going to be oriented always east-west, so which isn't the greatest thing to choose, but it is the way it was done. Come on in. Come on in. You can even sit down front if you want.
yeah.
Right. The receiver was a Flex 6700, 2 channels, 2 antenna inputs, giving me 2 simultaneous graphs, so you can see what the spectrum analyzer looked like. The conventional antenna is always displayed on top when I'm using a conventional antenna. And the ferrite antennas were hand-built. I made them. Ran the wood through a table saw. And I'll bring these up front and talk with them. Let me talk to these 2. So to keep all the stray inductance down, they were made out of wood. And I'll talk to what these are. You'll see them, but wait, let's pass this around. Let's pass that around. Be gentle with the wires. Okay. So what we have is we have a ferrite rod, and the rod length varies throughout this presentation. I'll tell you when they change. I start out with 50-inch rods, then 30-inch rods, then 60-inch rods, okay? So 3 different lengths. I started out all with 8 turns. So all 3 of the lengths only had 8 turns on them, but the results were quite a bit different, all right? 15 inches, yes. On this one it did. It did. And the reason you see these rubber bands at an angle, they are pulling them together. The rods are being pulled together because if you get the width of a sheet of paper between a rod, it's different, really different, okay? So this is a unity gain FET input amplifier, has a gain of 1, but an input impedance of 1,000,000 ohms. So I'm sensing the voltage at this point. Voltage is the same at this point. But now I can drive 50 ohms. This is a gain of 1,000 amplifier.
sitting up here from, that should be 0.2 to 2 gig. So I've raised that voltage up, I've raised the noise up by a factor of 30 dB, and I made 3 of them. So these are the 3 I brought today. 2 of the ones you see, they're in the configuration that the test ended in, with 2 of these configured for 30-inch ferrites. But the first one had just 2 rods. This has 4, and that has 8. So now, this is a top view looking down at the rods. That's west, so these are laying on an east-west orientation. And when you look at this is how I fed power to it. So I went perpendicularly away from the rod. It's a wooden roof, wooden joists, very little metal in the roof, nails sprinkled around. So it's fairly well floating. It's about 12 feet off the ground. It's a 9-foot wall garage. Let's see. So this red wire is how I fed 12 volts to it. So this is the back side. This is looking south. And each one, I came along the north side of the house and dropped down the wires and the power down to the antenna. So I'm keeping pretty far back, keeping orthogonal to the antenna itself to keep the interference out of it. This is what it looks from Google, right? The antennas, the rod antennas you saw here, short, medium, and long. This is one of the 260-foot off-center fed dipoles. The other one is orthogonal to it, both being fed from the same tower at this point. This is a vertical. It's a step IR vertical going straight up on top of this big metal building. And there's a horizontal step beam at the same tower that doesn't show up in the picture very well. That's what I'm doing. So we have 4 conventional antennas and these 3 rods. This is the pattern that the rods have. They are directional. When you're looking down the rod from the end, it's empty. It's empty. So they are directional. Now, these off-center fed dipoles are also directional, and they look like this. So they look like a chrysanthemum, all right? They're not symmetrical. They're being fed deliberately off-center, and the ratio of how they're fed is set so that these good SWR points fall on the amateur radio bands, okay? So it's easy to use. They're fun. You don't have to have a tuner with them, and they're reasonably close in SWR. But look what we have here. Here is 14 meg. I'm running a 30-inch ferrite antenna. It's the middle one, and I have this off-center fed dipole on here. Now, so we're looking east-west on the wire antenna. So it's an interesting result. This first one is interesting. Here the dipole has 17 dB gain on this particular signal, and the ferrite, this 30-inch rod, is actually a dB stronger than that signal, than this one right here, right? But look what's missing, all right? The ferrite rod doesn't see this big one. The wire antenna sees 3 signals here, but the ferrite sees 5. Now, here you have 2 signals present. You come down here, and they're much stronger on the rod. Remember this pattern. The wire antenna, we have no idea where these signals are coming from. No idea. But you've got nulls, 15 to 17 dB nulls here on these lobes here. This is a lot deeper. It's a 25 dB null or something like that. So when you look at it, if you look at the waterfall, you'll see a certain number of lines, stations, potential things you could talk to, and it gives you an idea that the wire antenna is obviously better. On most signals, it's better. There are some interesting things that, not so interesting on this slide. I'll show you another one. But there's some artifacts here. There's some noise that's coming into here that this one doesn't have. And remember, this antenna has a gain of 1,000 amps sitting on it. All right? Question?
So your off-center dipole is at what, 30 feet? Where was the ferrite cores?
12.
12 feet.
Uh-huh.
Okay. Same.
Yeah. So I then tuned up a station in Red Lion, Pennsylvania, so I had a known direction. All right? It's setting back here, so we're really setting in the null of what a dipole would look like. We're setting in the null of an off-center fed dipole. We're setting in the null of a ferrite rod. So I've disadvantaged them both only because I couldn't find a station. I I should have used CHU or something. But, so now I'm using a step IR beam. It's a dipole and it's facing north. So I have a dipole facing north, beams north, the null, and the ferrite also has a null. And here I've gone to the 60-inch long antenna. I've gone to this one laying here. And guess what? They're the same. I'm never looking at absolute signal to noise. So yeah, they perform the same. If you look at the waterfall, you'd say the beam is probably picking up more signal, or you know, a little bit more. There's less artifacts out here than this has, but they're of the same signal strength when I'm operating in a null. So there's at least a relevant test. It's, you know, you'd like to look at it in the beam path. So here's the same station in Pennsylvania, and I've got a 15-inch rod, the small one, 8 turns, and the 60-inch rod, 8 turns, same thing. But look at this. Now there's a 15 dB difference between them. So just going from the short rod with two rods in it this long, going to this one that has 60 inches, you've got actually 60 inches longer. There's a couple rods off this. I picked up 15 dB, but I still only had those little runty turns right in the center, right? 8 short turns in the center. So there's the first thing you take away from the presentation, is that more rods are better, all right? Now, here we go, commercial AM bar. Oh, we're still on the same thing, still in the 30-meter band, and I go to a vertical. And now we start getting some interesting things. This is an omnidirectional vertical antenna, but it can't see this signal or this signal or this signal that clearly show up here. And they have strong lines on the waterfall. The vertical doesn't see them. They're coming down at my physical location, horizontally polarized, right? They're coming down from the ionosphere. It's bifringent, so they come down corkscrewed and they come out at different angles. And I happen to not be getting vertical polarization coming in on these signals. And there's other little things that are becoming interesting, and that is some things show up. Nope, I'm not seeing them here yet. But again, I have high gain here on noise. In general, what happens is this guy's 45 dB signal to noise, and he's 30. So in terms of raw gain, the vertical antenna is working a lot better than the other one for this antenna. But you know, obviously it's receiving the vertical polarization part of the signal, and this one's receiving a horizontal polarization. They're receiving different stuff. You could combine these, and if you did, and you had that receiver right there sitting one antenna in each one, what you'll hear as the gray line sweeps across the Midwest, and you start getting these heavily scintillated fading paths, you'll hear the signal move in your head back and forth from the right ear to the left ear. But in general, you won't lose it. You won't lose it. Okay. So what do we have here? I went down in frequency. I went down to the low band, and this is, something's wrong. I'm doing something wrong with my coil, with my inductance, with the rods. It's not working right. So I threw that out. I tried something else. It's still poor, you know, different rod. So I don't have data below 9 megahertz on this presentation. It was cool. Oh yeah. See this? You're seeing the bandwidth of a step IR antenna. It's tuned here, right? And as you go away from it, the visor gets bad. Yeah. So now, I went back to 20 meters, gave up on the low band testing, and here's a 15-inch rod. And so we're looking at these. I put numbers on them this time, and you can kind of see what is happening. And you find out that there are signals that are just goofus. This little bitty rod has a lot stronger signal than this off-center fed dipole that's 260 feet long. So it depends on what you're looking at. Now, the waterfall shows everybody equally poor at this time, in 20 meters. It's about 11:30 or noon by this time. On Saturday, March the 6th, I think it was. It was on the first thing. So in general, it ranges from 1 to 10 dB worse, but it's 15 inches long. So here's a 30-inch version of the same thing, and now I get bigger numbers that are closer to the ones in top. I have, so it's, you know, the same to 6 dB worse instead of 10 dB worse. So I've gained 3-ish or 4 dB on this. But the point is, there's a lot of signals here. The band doesn't look hugely different. Now, in some cases, it's different signals, different polarization. So you can't really compare the two antennas directly because you got nulls in the various patterns on the big. And this has nulls off the end. So you may see east-west signals here and not down here, but you'll see north-south signals that would be in the nulls that you wouldn't find. So it's a complicated answer. Here's the 60-inch one. Now it's down to only 5 dB worse than the off-center fed dipole. So 60 inches is looking pretty nice, even though these are reasonably weak signals because the waterfalls are all faint.
So the signals on the left side here,
These?
the window we're not seeing.
Yeah, they're literally not seeing that. See that? Now, I don't know if that's a directional thing. It probably is. It might be a polarization thing, but I doubt it because these are both two horizontally polarized antennas. I think that's a directional aberration of my big, long, 260-foot antenna that I think is working so well. I'm not getting a signal and I don't know what's missing. When I'm normally operating, I don't know what's missing. But if I had two antennas and two receivers, and I'm listening with both ears, or combine them, I would definitely see that signal. So the summation, there's a place for both antennas, all right? Now we're going to get into the fun stuff. Here's the artifacts that I begin to notice. Look at this. Here's the east-west dipole, and I'm scanning from 15 to 21 megahertz, a big thing. Look at the signal levels here, and look down here. Everybody can't be in the null. All those signals can't be in the OCDF's null, but it doesn't see them. It doesn't see them. There's a wealth of signals here. All these would be excellent for digital modes. I've got almost 10 dB, 8 dB of signal to noise in some of these, down to 5. All these would carry digital signals in different modes. Olivia, Thor, you name it, they would run. But my big wire antenna, it doesn't see them. So there's something funny going on here. There's an artifact. And there's something else too. Look at this here. There's an aberration somehow in that antenna that integrates the noise power into a hump of noise. The noise rises. The non-information noise rises. So no antenna should be doing that, but it is. So there's two funny things that I discovered there. Now, when this is 15-inch ferrite antenna and a 60-inch ferrite antenna. They both have this goofy rising thing. And remember, I'm still running 8 turns. All I've changed is the various rod lengths so far. And you can see the behavior patterns are pretty much the same. And the 60-inch rod simply has more gain than the other one. But they're matching. They're oriented the same way. They have the same directivity. If you're missing a signal off the end, you're missing it on the top and bottom trace. So it's a fair comparison of whatever's out there to receive. And a bigger rod does have bigger signals. Moreover, these phenomena here are different. Look at that. Those are bigger on the shorter antenna. Not a lot, but it's some. It didn't. You might think it was. So there's something going on with weak signals that's interesting. Now, here's a wide scan on a lower frequency, 4 meg up to 10, and you can see that something is clearly going wrong with the rods down here. This is not normal behavior. The spectrum doesn't look like that. The spectrum doesn't have these big. I mean, this is a couple hundred kilohertz wide, and there's no broadcasters that wide in the band. So this is true data, and this is getting goofy. The rods are behaving. Remember, I went down to 40 meters and found funny behavior. Well, it extends down there. So there's something wrong at the low end. Now I changed the antennas. And what I did was I went from 8 turns, I then took, I went with 16 turns and 64 turns and made them all 30 inches long. 3 antennas, put them up on the roof, 30 inches long, they're all matching. I just had 8 turns, 16 and 64. Being, I gathered more voltage if I have more in turns, right? Now I realize I'm raising the inductance, and what happened was, it's terrible. This is what I put up there, 8 turns and 64 turns, but these were so terrible that I'm not even showing you what the results today. The gains were terrible. They had strange artifacts across the band. Those humps were all over the place. So I obviously took a turn and went in the wrong direction by just willy-nilly adding a lot of turns on my coil. All right, so doing a little bit of research, I called Dallas and talked to the guys down there. Frank Box, the VLF guy, antenna guy, he says, oh, bad thing. He said, you need less turns and you need to spread them out. So I spread them out, and it's what you see today, about 1.125 inches, 1.25 inches spacing between. So over 30 inches, I spread 60 turns out over 30 inches, and that's what's running around the room now. And look what happened. Look at this thing, it's flat. It's flat. And so this thing is 8 turns and 30 inches. This is the one I didn't change. You have these funky humps that come in here, and notice you don't have the distinction in the spectrum. Look at this stuff. All these signals are showing up down here, and they don't show up as well when I have the turns tightly together and the inductance is really high. Same number of turns. They both have the same number of turns. Oh no, I'm sorry, goof. That's 8 turns. I didn't run the 16 turn one because it was terrible. Now if you look at the waterfalls, we're getting more lines here, more strong lines, than we're getting up there. So the spectral distinction, the clear differentiation between these signals is more apparent than up here where they're blobbing and going down. So there's something good happening there. Now this is an 8-turn 30-inch rod, the 16-inch wide space, right? So we're comparing 2 rods, same attitude and orientation. The gains are about the same. Now the 8-turn one has about the same gain as the 16-turn one,